Hi guys, am I audible? Can you guys see me? Hi, can you guys see me? Okay, I hope you guys can hear me. Very well. Okay. Oh my god, there is some issue. Okay, let me just put things in order. Okay, otherwise I can't look at your live chat. Good evening, guys. Welcome back. My name is Madhu. I'm an astrophysicist from Bengaluru. I'm a young scientist already from Indian Science Congress and a young researcher already from European Space Agency, Netherlands. Regarding the NSEA program, there is a place where we look at this particular parameter of understanding the extra astronomical things. Like for example, we are going to need some what is going on in the current trends of astronomy. That is one of the places where they have where the NSEA syllabus says look at the podcast, look at the lectures of ongoing things which is going on, right? So in that context, looking at the civilization part becomes very important. So today we will be talking about quantifying the existence of extraterrestrial intelligence. Basically, we are talking about aliens uh, in different contextual words. And this program will be in English. Hi, Avir. Uh, hi, everybody. I can see many of you are here. Hi, Nagamunia. Hi. Hi, good evening. Welcome back. So today we are going to talk about Drake equation, Fermi paradox, and Kardashev scale. So basically, I'm going to give you the introduction and Drake equation, Fermi paradox, Kardashev scale, and we'll just discuss of what is going on. All right. Yeah. You love this topic. Brightburn, nice name. All right. So when we talk about Drake equation, Drake was an American physicist. So in many years ago, he just said in the 20th century, he just told us that there is an equation. He wrote down an equation with, you can see this number of variables, right? In this equation, it's just a product multiplication number, right? You can see in this particular slide the numbers, and these numbers sorry, these parameters like R, FP, NE, FL, FI, FCL. So you can see this is 1 2 3 4 5 6. There are 7 parameters we are talking about. Hi Saksham. So n is the number of civilization in our galaxy with which we might be able to communicate. Okay, we are talking about communication. And when we say R star here, we are talking about the average rates of the star formation in our galaxy. How, or like what is the time required for star formation to happen in our Milky Way galaxy? Like how is the birth happening? Like the giant molecular clouds combining to form the star. So the star formation where the circumstellar disk starts and where all the action starts, right? So that's where the star formation rate comes into play. Then FP is the fraction of those stars that is having planets. Not we know when we look at the sky, we have billions and billions of stars, right? We have billions and billions of stars. So when we talk about billions of these stars, not all stars have the planets. So exoplanets are orbiting certain planets, and there are some stars with multiple planetary system and some stars with one or two planets as well, and there are something called as rogue exoplanets as well. When I say rogue exoplanet, I'm talking about specifically planets without a host star, which does not have a star where they are orbiting. They are just like an orphan planet, which is like floating in space and time. And there are only the fraction of those stars which have planets orbiting around them. So that number also plays an important role. And then when we look at the next parameter, NE, the average number of planets that could potentially support life. We know all majority of our exoplanets right now are hot Jupiters. hot Jupiters are not good for existence of life. So we have to find Earth like or Mars like, basically rocky planets is what our interest is all about, rather than a gaseous poisonous planets. We talk about Drake equation. Drake equation basically tells us, is there a possibility of finding aliens, right? So that's what we are talking about right now. So are there any civilization in our galaxy that might be able to communicate intelligent form of life? So that is fun way to calculate. So, and FL is the fraction of planets that could support life where life actually emerges. Even though it might look Earth like planet, life might not emerge in that due to some astrobiological incident. And the next variable we talk about is Fi, the fraction of planets with life where intelligent life evolves. It need not be just microbial life forms in that particular planet, right? We have to look at intelligent life. When we talk about intelligence life, we are building artificial intelligence. That is a natural life form. We are expecting it to evolve out of the planet. So that is the fraction. That is also a small number. So the fraction then FC is the fraction of planets with intelligent life that develop the capability to communicate across interstellar distance. It should develop the technology. Like for example, we are able to send space telescopes, and we are able to send radio signals through big dishes throughout, and we are able to send signals. So we need to have a civilization which has the capability to build these things and send the signals, right? It should not be just like yeah, we have intelligence, we are not going to build anything for communication. So it should not happen in that way. So it has to evolve in that. Intelligence has to yield in a format where it can communicate across the solar system or interstellar distances, or as what we call it as. And the last variable L is the length of time these civilizations can communicate. How long can they communicate? That is also a very important question that has to be addressed, right? So how long, like the length of the time, whether this did they already do it, or are they gonna take much more time other than human beings evolution? So that we have to verify. That number is also a small number. So when you take a product of all these things, we get N is the number of civilization in our galaxy. We are talking about our galaxy itself alone, which has billions and billions of solar systems, right? With and in which some of them might be able to communicate. So Drake equation plays an important role. Any doubts regarding the Drake equation? Because this is one of the in NSEA they can ask a theoretical based question based on this. So I hope it is clear, because this is a 7 parameter big equation which can describe whether there is intelligent life out there or not. Okay. So this is how we can look at it in a neat way. So we are talking about our Milky Way Galaxy. This is our Milky Way Galaxy. I hope you can see the cursor. Black will be very difficult to see. Maybe I should use red. Okay. So this you can see. So this is basically the number of civilizations in our Milky Way. This is our Milky Way Galaxy. And in that star formation, this is one of the star formation regions in our galaxy. And the fraction of these stars which has planets around them, and number of these planets with an environment atmosphere like us, and how much biologically it can evolve. And then we talk about intelligent life, then we talk about technological capability, and then finally we talk about the time scale or the length at which this is happening. Just get me a second, guys. I think I was looking at your chat box and it somehow got messed up. Okay, so that's how we look at it. All right, all messages. Yeah, I can see all the messages now. All right. Now going back, now understanding the Drake equation, there is one more parameters, like the number of technological species over the history of the observable universe. So if you take that as A, okay, in the history of our observable universe, we are talking only observable. The ones we can't see, we can't tell anything about it. And then we have the number of habitable planets in the volume of the universe. So what is habitability? If there is a star here, if the planet is too close to the star, it is too hot. If the planet is too far away, it is too cold. But for an Earth-like planet, the distance is just right to sustain water and host life. So that way, these habitable planets number also very limited. And then we look at the likelihood of these species arising from one of these planets. So that is a different parameter. So if you just take habitable planets and the biological life format, you basically end up with the number of technological species that have formed. Somebody, sir, this is my first session. Oh, welcome. Hi. So Fermi paradox. So whenever somebody puts up a hypothesis, okay, there is always a contradiction. So whenever somebody says some statement, there is always a contradiction to that statement. And Fermi is a scientist who gave the contradiction to this particular statement. So it's called as Fermi paradox. So what does it apparently contradict is between the high probability of the existence of extraterrestrial civilization and the lack of evidence or contact with such civilization. Even though we talk about such a small number, this is basically a probabilistic number, right? This n is basically a probabilistic number we are talking about in the Drake equation. When we talk about Fermi paradox, what actually happens is, in reality, we don't have any evidence or contact of such civilization so far, okay, up to today's date. I know there is a lot of people who claims to be coming out to the news channels and saying that they have especially in front of the Congress in United States, there are some in the recent news you would have seen, there are some Navy veterans who have come out and said they have seen non-human biologics, which is a very bold statement to say. And as Carl Sagan says, extraordinary claims require extraordinary evidences. So we can't go just by those words, right? So in Fermi paradox, we can go step by step. In 500 years, if the home planet is formed, in 2000 years, this many number, then this many way the evolution goes, 5000 years like this. So 7.5 million years, galaxy completely colonized. It should have been colonized by this many number of million years, okay, which is 7500 basically around this many million years. And colonization time in millions of years. So cosmic timeline, you can see the oldest star in the galaxy being around this, then the formation of the earth, then the oldest known fossils, then we talk about the evolution of humans, and today what is happening. So it's a quite a long millions of years of scale. We will get to that. We will get to that, Roshan. So what are the key takeaways from the Fermi paradox? So as it is the contradiction to the Drake equation, the first point is vast number of potential civilizations. So the universe is vast with billions of galaxies, so many, each contains billions of stars, right? Many of such have planets capable of supporting life, many of them actually. Given the sheer number of opportunities for life to develop, it seems likely that intelligent life should have emerged somewhere. Okay, that is one of the vast number of potential civilizations, that is a key parameter. Then there is this is a limitation, lack of observable evidence. We are not seeing anything. Despite there is large potential civilization, we have not detected any definitive evidence for their existence. This includes not only direct contact but also indirect evidence also. We don't have no evidence such as signals, probes, or megastructures, advanced civilization. There are no stars which has very advanced structures that has been seen by our telescopes as well. So there is lack of observable evidence. Then the possible explanations. So the Fermi paradox has led to a variety of proposed explanations. Some suggest that the advanced civilization might have killed themselves, self-destruct due to technological or societal issues. They might have nuclear bombed themselves. and killed everything known to them. So that could be one of the reasons why we have not met the aliens still. They might have killed themselves, limiting their longevity. Others purpose that interstellar travel or communication is so difficult that we simply don't we have not encountered any civilizations yet, so they might not know how to build communications and do interstellar travel yet. That another idea that might be a galactic zoo intentionally isolated from other civilizations, or they might be hiding somewhere. There is a theoretical there is one theory where people think, like for example, if ant is moving on an apple, so it feels it's a two-dimensional space. According to ant, if it is moving on the apple, it feels it's a 2D plane, but we know as a person who is standing outside, it is a three-dimensional space. What if aliens are in a higher dimensions where we look where they look at us as ants? There is one of those possible hypothesis or crazy conspiracy theories that's running around. Okay, then we talk about great filter hypothesis. This is one of the important ones. The great filter is a concept that suggests there might be a significant barrier or challenge that prevents life from progressing to advanced space faring civilization. There might be some event happening where that is not allowing the space faring civilizations, it is not allowing it to become a space faring civilization. This could be something that occurs relatively early in civilization's development, which would explain the lack of observable extraterrestrial civilization. So this could be the reasons. And the fifth reason is limits of human observations. So our methods of searching extraterrestrial is need not be very good, so it might be limited by the technology what we have currently. Maybe we need to build much more better observational tools other than what we have currently. And if advanced civilization communicate to interact in ways we have not understood or can't detect, we might be missing out on their presence. As I told you, that conspiracy theory, it could lead to that particular parameter as well. Okay, that's about Fermi paradox. So it's very interesting to know that both of these particular things are very much in the lane of argument, right? In the line of argument, whether you can or cannot do something about it, right? Okay, you want me to talk about string theory and everything? If I keep talking about everything on the under the sun or everything in the universe, then all the cows come home in 30 minutes. Okay, so we talk about something called as Kardashev scale. This is a Russian scientist. In the year 1964, he classified the civilization based on energy consumption, how much energy we consume. Okay, so there are different types of civilization: type 1, type 2, type 3, and type 0 is a civilization currently we are in right now. This is our this is where we are located. So what does these types of civilization mean to us? So when we talk, you're saying 0.72 so accurately. Okay, so when we talk about zero civilization, it's just a ranking we are giving. So we call this as sub-global culture. This is a hypothetical civilization that has not yet achieved the ability to harness all the energy resources of its home planet. It is characterized by limited control over natural resources and reliance of basic energy sources like fossil fuels like petroleum products. They are able to just do the harness of that particular they say that's the word, that's the reason they use the word sub-globular. They don't use the word globular culture, because if you are able to use the word globular culture, that means you should be able to harness the energy of the entire planet. Then if this is type 0, then we talk about type 1 civilization, which is basically multiplanetary species. We are talking about planetary culture, what Elon Musk is trying to do, making humans multiplanetary species. Not just Elon Musk, many space agencies are trying to do, even though he has got much of the attention from the media. So I took his name as one of the examples right now. Okay, so when you talk about type 1 civilization, this is a civilization that has the capacity to harness and control all the available resources of its home planet. Means you should be able to harness the entire energy of our planet Earth. Okay, this includes renewable energy sources like solar power, wind power, geothermal power, all this. They can control weather patterns. We should be able to control the weather. Okay, when it should rain, when it should shine. Okay, earthquakes and volcanoes also, to a certain extent we should be able to control them. Okay, then we say we have achieved global unification of our species, and then we can make ourselves multiplanetary also, going to Mars and all those things. Those things add up to type 1 civilization. Then we talk about type 2 civilization. What do you mean by type 2 civilization? This is a stellar culture. Okay, this is the stellar culture. So our type 2 civilization has advanced to the point where it has to harness the energy output of the entire star. Okay, imagine there is a sun, and our sun, we build some kind of a Dyson sphere. Okay, it's a hypothetical big structure around the star. You are gonna build this Dyson sphere. So this Dyson sphere is gonna capture all the energy, and we use that energy for our space exploration. So this level of energy manipulation allows for significant advancements in science, technology, and space exploration. So building Dyson sphere around the star could make us evolve into, like, that's what even Drake was saying. When we talk about technological things, we have never seen any Dyson spheres around any other stars or any mega structures. Basically, it need not be just Dyson sphere, or any technological structures are not seen in any of those stars. So that could be one of the things that could be looked out for. Okay, then we have type 3 civilization. It's a galactic culture. Now we finished from we are in subglobular. Then we spoke about planetary, stellar. Now we are talking about galaxies. Okay, type 3 is a galaxy where you can control the entire galaxy, like building a big Dyson sphere around our own Milky Way galaxy, and able to harness the energy output of those billions of stars and manipulate the entire cosmic structure. Such a civilization would be would have a very deep understanding of physics, and might be able to do interstellar travel and colonize on a massive scale. It will be like Star Trek. Okay, it will be like Star Trek, going where no man has gone before. Okay, exploring new worlds. So that's where our type 3 civilization can lead towards. Yeah, it's currently science fiction. This particular part is currently science fiction. So this is gonna happen in, they are not saying this will happen tomorrow or in our lifetime. This may happen in millions of years. Okay, that's what, everything takes millions and millions of years. So imagine you, our civilization would have, this is very far thought towards the future. In the year 1964, Kardashev came up with this idea of scaling. He came up with this beautiful, simple, elegant scaling, just by the thinking that how much energy we are able to harness and convert that energy into resources. Okay, so that's the simple idea on which this particular scale was built, and this became a very, very beautiful way of doing the ranking system. So this plays a huge role. And just to give you a flavor, guys, if I was talking in the last class, somebody asked me what is a tardigrade. So in order to show you what is a tardigrade, this is a small microbe. It has 6 legs, water bear microbe. It has 6 legs. And me and my team, we have discovered a similar family species. Means you get into a, like, from the Himalayas, what I was talking about in the last class. Those who are present would know what I'm talking about. If you have not been in that class, you just go to the previous live session of mine. I think the name of that particular session was Twin Earth or Earth 2.0. There I have introduced myself and my work on tardigrades, for which I received the Young Scientist Award from Indian Science Congress Association. This has a shell like tortoise. Okay, so this is how the shell of the tortoise, if they go inside this shell, we have 2 states, cryptobiotic and anhydric state. Okay, so in these states, means once getting inside and coming out, they can survive. When they are inside the shell, they are able to survive for much harsher conditions. So these are some of the extremophiles. These are water extremophiles, water-based extremophiles. I'm giving you a flavor of astrobiology because the reason why I'm giving you this is they have used the word current, whatever popular sciences are going on, that has to be known. So this is one of the popularly going on topic in astronomy. So I think knowing about tardigrades, and there are microbes. There is a mission by Russia, mission that's going on in International Space Station ISS. So in the International Space Station, what they are doing is there is a module called expose. So in that expose modules, they are able to do experiments on these microbes, and they are able to do experiments, and in the International Space Station they are also experimenting on food like microgreens and other things. So this was just to touch up on the flavors of astrobiology as we are going to the end of as we go towards the end of the studies in the NSEA program. Okay, so just to give you a flavor, if you have not enrolled, I really request you to get on with it, because the time is something which we don't have. NSEA exams NSEA exams will start on 25th November. Okay, I think you need time to prepare for this, and I want you guys to bring gold medals to our country. Okay, and Olympiad is one of the places where you can back gold, and I will be helping you to do that. So if you want my help, and if you want to learn this in detail, I would really recommend you to get into the description, and only couple of classes are done. So join the program, and we will, and the only those last two sessions recordings will be available. There will be a lot of quizzes, assignments given to you in the paid program. I really request you to work with me, and once we work together, I think we will be able to understand, not just win gold medals for India, but also understand the great mysteries of the universe. So both the things we will do hand in hand in the sessions at Vedantu. If you have not enrolled, get into the description and do enroll, and see you in the next class. Until then, have a nice day and take care. This is Madhu signing off.